Hi friends, so in this session we are going to solve one problem on forced vibration. To solve this problem, see they have given that a vibrating body of mass 150 kg. So the given is mass of vibrating body is 150 kg. Supported on springs of total stiffness, means spring stiffness is given and it is 1050 kilonewton per meter. It has a rotating unbalanced force of 525 Newton. So I'll write here unbalanced force. Now what is this unbalanced force? Before moving to the next given, we'll talk. See, in forced vibration, there is one term called vibration due to rotating or reciprocating masses. So consider one rotating mass. Suppose this mass m0 is rotating. Its radius from this point is suppose e and rotating at speed omega. Then the centrifugal force acting on this mass will be m omega square r. Here we have considered the radius is e and the mass is m0. Means in this system, in this rotating unbalance, the unbalanced force which is m0 omega square e. And if we resolve this one, then the vertical component will come as m0 omega square e sin omega t. Okay, so this is the unbalanced force in any rotating system. So I'll complete this rotating system. Suppose this system is having mass m supported with one spring and damper. So spring will be k, damper will be c, and this system having total mass m. Okay, and in this total system there is one rotating unbalance, and that rotating unbalance is it is having the centrifugal unbalanced force, and that is m0 omega square e. And they have given this unbalanced force, means they have given the directly value of m0 omega square e, and that is equal to 525 Newton. Okay. Now next, at a speed of 6000 rpm. So they have provided the speed, and that is equal to 6000 rpm. If the damping factor or the damping ratio, means zeta, is given by 0.3, determine the amplitude and phase angle due to unbalance. Now, in the rotating unbalance, the formula for amplitude is f0 by k divided by under root 1 minus omega by omega n square, then total bracket square, plus 2 zeta omega by omega n bracket square. So this is the formula to determine the amplitude. Now here, instead of f0, they have given the unbalanced force, and that is the m0 omega square e. So this f0 I am going to replace by m0 omega square e. So this formula will become m0 omega square e divided by k divided by this root. Okay, so here just we will have to replace the f0 force from the forced vibration amplitude formula. So this is the formula for amplitude. So here I will write amplitude of forced vibration. Along with the amplitude, they have asked for the phase angle. This phase angle is given by tan phi is equal to 2 zeta omega by omega n divided by 1 minus omega by omega n bracket square. So this is the formula for the phase angle, and they have asked only these two values, that is determine the amplitude and determine the value of phase angle. Now from this formula, whatever the values we know and we don't know, that we will first identify, and the values which are required to put into this formula, that we are going to determine. So from here we will solve. To solve, see, they have given the m naught omega square E, they have given the value of k. See, here we have k, that is the stiffness. Here we have m naught omega square E. So this numerator is given. Now think about this denominator. In the denominator we have the value of omega and omega n. So here they have not given omega and omega n. So initially we will determine the value of omega and omega n. Now omega n is the natural frequency. So the natural frequency will determine omega n is equal to root k by m. Put the values. So they have given the value of k 1050 divided by value of m, it is 150 kg. Okay, put the values on calculator, we will get the answer of omega n. The answer of omega n is, it is 83.66. 83.66. Now the unit is radian per second, because it is angular frequency, angular velocity. Now this is the natural frequency of that particular system. Now along with this omega n, will require the value of omega, means actual working frequency of that system, means angular velocity. So the angular velocity of that system, omega, it is 2 pi n divided by 60, and they have given the velocity of rotation, that is 6000. So 2 pi 6000 divided by 60. And this value is 2 pi 6000 divided by 60. This comes out to be 628.31. 628.31 radian per second. So we have the value of omega n. So from this formula we have determined omega n, but we will require the ratio of omega by omega n. So now we will take the ratio of omega by omega n. So it is 628.31 divided by 83.66, and this ratio is 7.51. This ratio is 7.51. So this is the ratio of omega by omega n. So we can directly put this value into the formula. Okay. Now in the formula, see what more terms that we require. We know this omega by omega n now. We know this value. Now zeta they have already given, means we know all these values. Now we will have to just put all these things into the formula, then we will get the answers. Okay, so I'll write the first answer, amplitude of this vibration, that is the first vibration, amplitude of vibration. What is the formula for this one? Amplitude of vibration, it is x is equal to m naught omega square E divided by k divided by root 1 minus omega by omega n square bracket square plus 2 zeta omega by omega n bracket square. So put all the values. So in the problem they have given the value of m naught omega square E, and it is 525 Newton. So 525 divided by, they have also given the value of k is 1050. Just check the unit of 1050. It is, just check, it is kilonewton. So we'll have to convert into Newton. So 1050 into 10 raised to 3 Newton per meter. So 1050 into 10 raised to 3. So divide by 1050 into 10 raised to 3. So this is the numerator, complete numerator. Divide by root 1 minus omega by omega n, that we have determined 7.51 square, then whole bracket square, plus 2 into, they have given the value of zeta, and that is 0.3 into omega by omega n, 7.51 bracket square. So all this complete. So after putting all the values, we will get the amplitude, that they have asked the answer of amplitude. Okay, and it comes out to be 8.99 into 10 raised to minus 6 meter. So this is the answer, amplitude of vibration. Now along with this amplitude, they have asked for the phase angle. So the phase angle, is nothing but tan phi is equal to 2 zeta omega by omega n divided by 1 minus omega by omega n square. So put the values, we know all these values. So it is 2 into zeta is 0.3 into omega by omega n is 7.51 square. Sorry. It is only omega by omega n. So I am going to erase this one. There is no square. So it is 2 into zeta, the 0.3 into omega by omega n, 1 minus 7.51 square. So solve this side and take the tan inverse, you will get the answer. Solve and take the tan inverse, and this comes out to be minus 4.63 degree. After solving, you will get the answer minus 4.63. Okay, so I quickly revise this one. See, in the problem they have given a rotating unbalance. Okay, and this rotating unbalance means it is the forced vibration. So in the forced vibration, we know the amplitude and the phase angle. So the formula for amplitude is F0 by K, but instead of F0 they have given the rotating unbalance, means unbalanced centrifugal force, as shown in figure. So this is the unbalanced centrifugal force, that is the m0 omega square E. So I have directly taken this value, m0 omega square E is equal to unbalanced force. Okay, then the remaining terms, F0 by K divided by root 1 minus omega by omega n square bracket square plus 2 zeta omega by omega n square. So in this formula we don't know the value of omega and omega n, so we have determined initially the values of omega and omega n. Omega n is nothing but root k by m. So the first formula that we have is root k by m, and the second formula that we have is 2 pi n by 60 to determine the omega. After getting this omega and omega n, just we have entered all these values into the formula of amplitude and phase angle, and we got the answers. Thank you.